Okay, so remember the theorem we want to prove is the following. Let gamma be a lattice of a connected Lie group G, and let F be a one parameter subgroup. With the Hausdorff dimension of the set of points divergent on average recall that this is a sub-semigroup of this one parameter subgroup where t is greater or equal to 0, and the divergent on average means the limit as t goes to infinity of the average of this integral is 0 for all compact subset K of G mod gamma. The idea of the proof begins like this. First, we want to reduce the proof to the case when G is semi-simple. And then a semi-simple group G can be embedded into SL KR for some K. And then F has a Jordan decomposition. Which we will now describe. Let G be a connected semi-simple Lie group for any one parameter subgroup F. They are uniquely determined one parameter subgroups. So KF, the elements are denoted K sub T, where T is in R. The AF A sub T, where T is in R, and U sub F, U sub T, T is in R, with the following properties. First, so F sub T, each F sub T can be written as the product of K sub T, A sub T, and U sub T. And second, KF is bounded. AF is diagonalizable over R. And UF is unipotent. And finally, all the elements of KF, AF, and UF commute with each other. And those three groups all have names. So this is called the compact part, and this is called the diagonal part, and this is called the unipotent part. Of F, respectively. And now we will reduce the theorem, the proof of this theorem, to the following theorem using the terminologies we introduced in here. The theorem says, if you have a group a subgroup of SLKR, which is a connected center-free semi-simple Lie group without compact factors, and let F be a one-parameter subgroup such that the compact part is trivial. But the diagonal part A sub F is non-trivial. Furthermore, we assume the following hold. First, that G can be written as a direct product of connected normal subgroups G sub i's. And second, this lattice gamma can also be written as a direct product of non-uniform irreducible lattices. By non-uniform here, we mean it is not co-compact. And by irreducible here, we mean it cannot be written further as products. And thirdly, we assume the group A sub F, namely the diagonal part of F has non-trivial projection to each G sub I. So if those are assumed, we can conclude That's a Hausdorff dimension of the set of points whose orbits are divergent on average with respect to the semigroup is strictly less than the manifold dimension of G mod gamma. This is the theorem. And it turns out if we can prove this theorem, then we can prove this one. And of course this needs some effort. This is not obviously how this theorem will immediately implies this one.